So if you look up basic solar data today, like if you just pull out your phone right now and search for it, modern science will tell you that the physical sun, that glowing ball we see up in the sky, is roughly 1.39 million kilometers across.
Right. It's an absolute monster.
Yeah, exactly. It's massive.
Right.
But if you rewind a few thousand years and read some of these ancient Indian cosmological texts, like the Shrimad Bhagavatam, you find these ancient astronomers confidently claiming that the sun's globe is only about 130,000 kilometers wide.
Which is a huge discrepancy.
Oh, it's a staggering discrepancy.
Okay.
And for centuries, modern scholars looked at that and just kind of, laughed at it. They called it a primitive error. They filed all these texts away as nothing more than mythological fairy tales, basically assuming our ancestors were just looking up at bright dots in the sky and making up poetry.
Well, yeah, because it's easy to dismiss what you don't understand, right?
Totally.
Mm-hmm.
But that whole comforting narrative, that sort of chronological snobbery, it completely falls apart when you look at what happened when astrophysicists finally developed the technology to peer beneath the sun's surface and actually measure its internal nuclear core.
And the paradigm shift there is just absolute, because when you stop treating these ancient Puranic texts as literal physical geography, and you start analyzing their numbers, their geometry, their celestial descriptions through the lens of modern orbital mechanics, you uncover something entirely different.
Yeah.
They're looking at highly sophisticated mathematical models. I mean, these are hard astrophysical realities encoded in this sort of, well, a language of metaphor.
Right. And that is exactly why we're here today. Welcome to the Deep Dive, everyone. We are setting up what is basically the ultimate clash of eras today. It's ancient mythological poetry going head-to-head with modern high-tech astrophysics.
It's going to be a fun one.
It really is.
Yeah.
We are pulling from this fascinating stack of analytical notes that compares the Shrimad Bhagavatam, the Vishnu Purana, and the Matsya Purana with the hard data from NASA and, contemporary orbital mechanics. Our mission today is to decode these ancient texts by comparing ancient measurements, specifically this unit called the Yojana, directly to the modern core data of these celestial bodies.
What's fascinating here is the sheer scale of the abstraction. I mean, these ancient rishis, the sages who actually compiled these texts, they were essentially running a three-dimensional mathematical simulation of the cosmos in their minds.
Without computers.
Exactly. They lacked radio arrays, they lacked, the James Webb Space Telescope, yet they calculated the operational mechanics of the solar system with a precision that we are honestly only just now verifying with billion-dollar spacecraft.
Okay, let's unpack this, because I think the easiest trap for any of us to fall into is just dismissing a text simply because it uses unfamiliar terminology, right?
Yeah.
Like, oh, it's poetry, it doesn't mean anything. So to really test this hypothesis for you listening, we have to start right at the center of our solar system.
The sun.
Yep, the sun. We need to look at the most audacious mathematical claim in our sources, which is the specific measurement of the sun itself.
Right. So, in the 5th canto, chapter 24 of the Shrimad Bhagavatam, there's this meticulous description of what they call the Surya mandala, which translates to the sun globe. And the text explicitly states that the span, or, the diameter of the Surya mandala is 10,000 Yojanas.
Okay, and for you listening, a yohian is the standard ancient unit of astronomical distance. Our sources break down the conversion metrics for this, and while there is a slight historical variation in how it's calculated, the most rigorously accepted standard puts 1 Yohana at roughly 8 miles.
Which is about 12.87 kilometers.
Exactly, 12.87 kilometers. Now, there is a secondary metric used in texts like the Surya Siddhanta that calculates it a bit higher, closer to 9 miles. But we can establish a solid working range using both. So you take 10,000 Yojanas and multiply it by 12.87 kilometers. That gives us a diameter of roughly 128,700 kilometers.
Yes.
And if we use that 9-mile maximum, we cap out at about 144,000 kilometers.
So we basically have a clearly defined bracket here, anywhere from 128,000 to 144,000 kilometers.
Which brings us right back to that giant glaring problem I mentioned in the hook.
Yeah.
Anyone who has ever opened a high school astronomy textbook knows the sun is just a monster.
Oh, absolutely.
I mean, the photosphere, that outer glowing yellow envelope that we actually
Right.
see when we use like a solar filter, is 1.39 million kilometers across. So the ancient text is off by an entire factor of 10. I mean, on paper, it really looks like they just threw a dart at a board and picked a random large number.
Right. And if we assume they were trying to measure the exact same thing we measure with our optical telescopes today, then yeah, it looks like a massive error. But if we connect this to the bigger picture of stellar physics, the entire context shifts.
How so?
Well, the sun is not a solid billiard ball, right? It's this incredibly complex onion of boiling gas and plasma. That 1.39 million kilometer photosphere is merely the outermost visible layer. It's essentially the exhaust.
Right, it's just the gaseous shell on the outside.
Exactly. The true engine of the sun, the actual physical structure that's generating all the gravity and that immense energy that defines our entire solar system, is buried deep beneath that glowing envelope. We call it the core.
Okay.
Now, modern science calculates the total radius of the sun at roughly 696,000 kilometers. And helioseismology, which is the study of wave oscillations inside the sun, basically how sound waves travel through it, that has allowed astrophysicists to determine that the active fusion furnace, the core itself, extends from the absolute center out to about 20 to 25% of that total radius.
Wait, okay, let me do the math on that real quick. If the total radius is 696,000 kilometers and the core is 20% of that, 20% of 696,000 is exactly 139,200 kilometers.
Exactly. The radius of the sun's core is just over 139,000 kilometers. Now, look back at that Puranic measurement.
Oh, wow.
10,000 Yojanas gives us a bracket of 128,000 to 144,000 kilometers. The numbers align perfectly.
That is insane.
Right. The ancient texts weren't measuring the fluffy, gaseous outer shell at all. They were measuring the radius of the sun's internal nuclear core.
That is, I mean, it's like measuring a car by the size of its engine rather than the chassis.
That's a great way to put it, yeah.
They bypassed the visual illusion of the sun's outer atmosphere, which is the only thing you can actually see with the human eye, and they somehow mathematically zeroed in on the nuclear reactor itself. I mean, they didn't care about the glow, they cared about the actual source of the power.
And to truly appreciate the sophistication of focusing on the core, you have to really understand the physics of what is happening inside that 10,000 Yojana sphere, because it is an environment of just unimaginable violence.
I can't even imagine.
The temperature is around 15 million degrees Celsius, and the gravitational pressure is so immense that matter can't even exist in a normal state. Gases are crushed into this incredibly dense plasma, and the electrons are violently stripped away from their atomic nuclei.
So it's a completely different phase of matter altogether.
Exactly.
Yeah.
And under that crushing pressure, hydrogen protons are literally forced together. Now, normally, protons naturally repel each other, right?
Yeah.
Due to the electromagnetic force.
Like two positive magnets pushing away from each other.
Precisely. But the environment in the core is so extreme that they undergo what's called quantum tunneling. They overcome that natural repulsion in a process known as the proton chain reaction. And this is the crazy part. Every single second, 600 million tons of hydrogen fuse into helium.
Wait, 600 million tons of matter.
Yes.
Reacting every single second.
Every second.
The scale of that is almost impossible to visualize. I mean, just thinking about a single ton of matter and then multiplying that by 600 million every second.
And tying this back to Einstein's mass energy equivalence, EMC2, that reveals the true function of the core. When those protons fuse, the resulting helium nucleus is actually slightly less massive than the original hydrogen protons.
Wait, so where does the mass go?
About 0.7% of the mass simply vanishes, but it doesn't actually disappear, right? Physics tells us it can't. It is converted into pure, blinding energy. So every second, 4 million tons of physical mass inside that specific core radius is transformed into the energy that radiates outward and sustains our entire planetary system.
4 million tons of mass turned into pure energy every second.
Yep. That is exactly why the ancients define the Surya mandala by its core. The 10,000 Yojana sphere is literally the beating heart of our reality.
Which completely validates their approach. I mean, it's brilliant. Yeah. But, okay, this actually creates an immediate, massive contradiction when we look at the rest of the text. Because if they were so astonishingly accurate about the sun's core, their data on the moon seems, well, completely unhinged.
Ah, yes. The lunar anomaly.
Yeah, because the Puranas, the sun's mandala is 10,000 yojanas. But in the exact same chapter, they state that the moon's mandala is 12,000 yojanas. I mean, on the surface, that is a ridiculous claim. The physical moon, the actual rock that our astronauts landed on, is only about 3,474 kilometers across. It is a tiny, tiny speck compared to the sun. So how could a civilization that is capable of calculating stellar cores possibly claim that the moon is larger than the sun?
Well, this is where it gets interesting, because this requires us to translate conceptual frameworks, not just language.
Okay, what do you mean by that?
So the Sanskrit word used there is mandala, And we, in the modern era, lazily translate that to globe or sphere, which implies a solid physical boundary, right? Like a ball of rock. But in ancient cosmologies, mandala carries a much broader connotation. It can mean a halo, an aura, or an operational sphere of influence.
Wait, so if the modern hill sphere is 132,000 kilometers, and they used an 11-kilometer yagana, they aren't mapping the physical rock at all, are they? They're mapping the gravitational boundary.
You've jumped right to the modern astrophysical equivalent, but yes, exactly. Let's break down the Hill sphere for a moment for the listeners. In orbital mechanics, this was originally defined by the American astronomer George William Hill back in the 19th century. A Hill sphere is basically the region in which a celestial body dominates the attraction of satellites.
Okay.
The moon isn't just a dead piece of rock floating in space. It carries an invisible, three-dimensional gravitational bubble around with it everywhere it goes.
So even though Earth has this massive gravity, well, there is a specific pocket of space around the moon where the Earth's gravity essentially takes a back seat.
Exactly. If an object enters that specific bubble, it orbits the moon, not the Earth. And modern science calculates the radius of the moon's Hill sphere to be somewhere between 58,000 and 66,000 kilometers, depending on where it is in its elliptical orbit.
Okay, meaning the total diameter, like the full width of this invisible gravitational bubble from edge to edge, is roughly 132,000 kilometers.
Right. So let's apply the ancient math again. The moon's mandala is given as 12,000 yojanas. Now, if we use a slightly more conservative historical metric for this calculation, where 1 yojana equals exactly 11 kilometers, 12,000 multiplied by 11 is exactly 132,000 kilometers.
Wow.
And even if we use the larger 12.87 kilometer metric we used earlier, it yields roughly 154,000 kilometers, which maps beautifully to the outer tapering boundaries of the Hill sphere's gravitational influence before it completely fades into Earth's pull.
So they weren't measuring dirt and craters, they were measuring the operational zone of gravity. And honestly, when you think about it, why would they care about the rock itself? The rock itself doesn't impact Earth. The invisible gravitational bubble is what actually reaches across the vacuum of space, grips our oceans, and creates the tides.
That's the key right there. They mapped operational zones of energy. The moon, as a functional, interactive entity in the cosmos, is defined by its gravitational reach, not its physical surface area. So when the Shrimad Bhagavatam compares the sun's core, which is 10,000 yojanas, to the moon's gravitational sphere, which is 12,000 yojanas, the text is actually mathematically sound.
Yeah.
The moon's operational mandala actually is larger than the sun's inner nuclear core.
That reframes the entire document for me. I mean, we are literally reading a physicist's chalkboard, not a mythology textbook, which I think sets us up perfectly to look at the third major entity introduced in this cosmic hierarchy.
Yeah.
Because we have the sun, we have the moon, and then we have the shadow that swallows them during an eclipse, Rahu.
Rahu, the dark planet.
Yeah, and the sources outline a hierarchy here that gets even stranger. So we established the sun's core is 10,000 yojanas, the moon's sphere is 12,000, and Rahu is clocked at 13,000 yojanas.
Right.
Making it the largest of the three. But modern astronomy tells us Rahu isn't a physical planet at all. It doesn't have a surface. It is a lunar node. It's basically the mathematical intersection point where the moon's orbital plane crosses the Earth's orbital plane around the sun.
Exactly. It is the precise geometry required for an eclipse to occur.
But my question is, how do you measure a mathematical intersection? If Rahu is just an orbital crossing point, this invisible node, how can it have a physical diameter of 13,000 yojanas, which, translates to roughly 167,000 kilometers?
This raises one of the most stunning correlations in our entire deep dive today. Because to understand how an empty point in space can have a measurable physical diameter, we have to explore the physics of Lagrange points.
Okay, Lagrange points. Those are those cosmic parking spots where we put space telescopes, right?
Exactly. So back in 1772, the mathematician Joseph-Louis Lagrange published an essay on the three-body problem. And he discovered that when you have two large orbiting bodies, like the Earth and the Sun or the Earth and the Moon, their gravitational fields interact in a way that creates 5 specific points in space.
And these are labeled L1 through L5.
Right. At these very specific points, the gravitational pull of the two large masses exactly equals the centripetal force required for a small object to move with them.
So it's essentially an invisible gravitational trap. The forces cancel each other out to create this stable pocket.
That's a perfect way to describe it. Now let's focus on L2 in the Earth-Moon system, or even the Earth-Sun system. L2 is always located directly behind the smaller body on the exact mathematical line connecting the two. So by its very orbital mechanics, it always sits in the shadow.
Oh, that makes sense.
Yeah, in fact, NASA parked the James Webb Space Telescope at the Sun-Earth L2 point precisely to keep it permanently shielded from the sun's heat, essentially utilizing the Earth as a giant permanent sunshade.
Which is completely identical to the Puranic description of Rahu. I mean,
Right.
it is explicitly described in the text as a shadow entity, right? A creature of darkness stationed directly opposite the light.
Exactly, but here's where the actual measurement comes in. A Lagrange point is not a microscopic pinprick in space. You don't park a multi-billion-dollar telescope on a single dot. These points are massive, three-dimensional gravitational wells. Satellites at L2 actually orbit around the invisible center point in these massive sprawling paths known as halo orbits or Sagittarius orbits.
Wait, they orbit an empty patch of space?
Yes. The physics of the rotating reference frame forces them into this massive halo around the point. And modern astrophysics measures the diameter of these specific halo orbit regions, along with similar dust-trapping gravitational eddies at L4 and L5, which are known as Kordylewski clouds, at roughly 150,000 to 160,000 kilometers across.
Okay, let me pull up the ancient math again.
Right.
Rahu is given as 13,000 Yojanas. If one Yojana is 12.87 kilometers, 13,000 multiplied by 12.87 equals exactly 167,310 kilometers.
And honestly, the margin of error there is basically rounding dust on a cosmic scale.
So what does this all mean? The ancient astronomers didn't just invent a mythological demon to explain the lights going out during an eclipse. They mathematically calculated the exact width of invisible gravitational traps in a vacuum.
That's exactly what the data suggests, yes.
They knew that the shadow zone, this gravitational eddy where eclipses actually occur, was roughly 167,000 kilometers wide. It mathematically supersedes the moon's Hill sphere of 132,000, and it supersedes the sun's core of 139,000. So the Puranic hierarchy, 10,000, 12,000, 13,000, is not a ranking of physical rock size at all.
No, it's not.
It is a meticulous ordering of invisible cosmic mechanisms based on their spatial volume.
And it requires a level of abstract deduction that is just breathtaking. I mean, they mapped regions of space containing absolutely no solid matter whatsoever, defining them entirely by their gravitational boundaries and operational geometry.
It's mind-blowing. Okay, so we have established that their static measurements were profoundly accurate. But the solar system isn't static, right? It is this chaotic, violent dance of moving bodies. If they didn't have reams and pages of calculus to map out all these elliptical orbits, how do they encode the dynamic movement of the planets?
Well, they use a metaphor that a civilization rooted in antiquity would immediately understand. Cosmic chariots drawn by horses. And the physics encoded within this specific metaphor is incredibly dense.
Yeah, because looking at the sources, there's a huge numerical discrepancy that pops out immediately when you look at the chariots. The texts state that the planets, Mercury, Venus, Mars, Jupiter, Saturn, and the Moon, they all ride in chariots pulled by 8 horses.
Right, mostly 8.
Yeah, the Moon actually has 10, which I know we will analyze shortly. But the Sun, the most massive, powerful body in the sky, its chariot is only pulled by 7 horses. Why the missing horse?
To decode this, we have to understand that in the framework of orbital mechanics, a horse pulling a chariot is actually a vector of force. It represents a specific gravitational pull.
Okay, so a horse equals a physical force vector.
Exactly. Consider a planet like Mars. It doesn't just float peacefully in the void. It is engaged in this massive, multi-directional cosmic tug-of-war. It is constantly being pulled by the sun, by the Earth, Jupiter, Saturn, Mercury, Venus, and the Moon.
So it's being yanked in every direction.
Right. 7 major celestial bodies are constantly exerting gravitational influence on it. Those are 7 external gravitational vectors. So 7 horses pulling the chariot in different directions.
But wait, if there are only 7 major external poles, why do all the planetary chariots have 8 horses?
This is a beautiful articulation of the n-body problem and Newton's laws of motion.
Right.
If Mars only experienced those 7 external gravitational poles, it would ultimately just plummet right into the very center of the solar system and be incinerated.
It would just crash into the sun.
Exactly. So what prevents that orbital decay? Its own inertia. Its forward tangential velocity.
Right, the speed it carries perpendicular to the gravitational pull.
Precisely. Gravity pulls it inward, inertia pushes it forward, and the precise balance of those forces creates a stable, curved, elliptical orbit. To keep the chariot of Mars stable on its path, you require the 7 external vectors of gravity plus the 1 internal vector of its own momentum. 7 plus 1 equals 8. 8 horses maintain a stable planetary orbit.
That is so elegant.
It is. Now, alternatively, some modern interpretations view these 8 horses as representing the 8 directional vectors of two-dimensional space, so north, south, east, west, and the 4 subdirections, maintaining spatial equilibrium. But the mechanical logic remains identical either way. 8 vectors equate to a stable planetary orbit.
That is just a staggering way to visualize orbital mechanics. But that circles us right back to the anomaly of the sun. If the planets need 8 vectors for stability, why does the sun only have 7? Doesn't the sun need to be balanced in its orbit too?
Well, the sun is fundamentally different from every other body in our local system. It holds 99.8% of the entire mass of the solar system.
Wow. 99.8%.
Yeah, it is the barycenter. So it isn't being violently yanked around by planetary gravity in any really meaningful way. It is the master anchor for everything else. Therefore, it does not require the 8 horses of gravitational and inertial balance to maintain its position.
Okay, so if the sun's horses aren't gravitational vectors, what force do they represent?
They represent energy vectors. The Rig Veda and the Vishnu Purana both suggest the sun travels through the cosmos not by the push and pull of gravity, but by radiating energy. The 7 horses of the sun represent electromagnetic radiation, specifically the 7 primary frequencies of the visible light spectrum.
Which we know today as the spectrum of visible light that refracts through a prism, right?
Yeah.
Like Roy G. Biv.
Exactly. In modern quantum physics terms, these are the 7 primary energy states of photons radiating across the universe. So metaphorically speaking, the sun's chariot is propelled by light itself.
That's beautiful.
Yeah.
But our sources mention an anomaly in the sun's chariot that seems incredibly specific. I want to get your take on this. There is an 8th entity involved in the sun's chariot, but is not a horse. It is the charioteer.
Yes, a rune.
Right, and the text described this charioteer named Arun, which means dawn, as being legless or crippled. Why on earth would they put a legless driver in charge of the most powerful chariot in existence?
Because it is a flawless scientific encoding of a major astrophysical discovery.
Really?
Absolutely. So we have the 7 horses representing the visible light spectrum, but there is another form of solar radiation that arrives just before the visible light at dawn. In the year 1800, the astronomer William Herschel conducted this famous experiment with a prism and some thermometers.
Okay.
And he discovered a form of light just beyond the red end of the visible spectrum that carried immense heat, but it was completely invisible to the human eye.
Oh, infrared radiation.
Infrared. It drives the energy forward, it always arrives first, and it dictates the thermal dynamics of the entire solar system. But it has no visible physical legs, you cannot see it. Arun, the legless charioteer of dawn, is the invisible ray of thermal heat that guides the 7 visible rays of light.
Oh, wow.
The ancient texts literally encoded spectroscopy and thermal radiation into a metaphor about a driver without legs.
That is just phenomenal. I mean, we've established that the sun has 7 horses for electromagnetic energy, and the planets have 8 horses for gravitational and inertial balance. But then we look at the moon. Our sources indicate the moon's chariot is pulled by 10 horses. Is that just a mythological exaggeration to make the moon seem more important?
Far from it. It represents perhaps the most sophisticated orbital calculation in all of the texts.
Really? 10 horses?
Yes. Because the moon's orbit is incredibly complex. It orbits the Earth, but it is also heavily influenced by the massive gravity of the sun. But the critical variable here is that the moon does not orbit on the exact same flat plane as the Earth and the sun. Its orbit is actually tilted by approximately 5.14 degrees relative to the ecliptic plane.
Okay, so it's misaligned.
Exactly. Because of this 5.14 degree tilt, as the moon travels along its path, which naturally requires the standard 8 directional vectors we talked about for planar stability, it also dips above and below the ecliptic plane. It physically moves up and down relative to the Earth-Sun line over the course of its cycle.
So it requires vertical force vectors to account for that up and down notion.
Precisely. In orbital mechanics, we map these exact intersection points as the ascending node and the descending node. It essentially requires an upward pull toward the zenith and a downward pull toward the nadir to explain the geometry.
Which the Puranic texts identify as the influence of Rahu and Ketu.
Exactly. The upward pull of the north node, which is Rahu, and the downward pull of the south node, which is Ketu. So to maintain the moon in its highly specific, wobbly, tilted orbit, you require the 8 planar vectors plus the 2 vertical vectors. 8 plus 2 equals 10. The 10 horses of the moon represent the precise 10 vectors required to mathematically resolve the three-body chaos of the lunar orbit.
See, here's where it gets really interesting to me, because the metaphor doesn't stop at just the quantity of horses. The visual descriptions of these planetary chariots map flawlessly onto modern planetary spectroscopy.
Oh, the albedo data, yes.
Right. When modern astrophysicists look at planets, they study their albedo, which, for you listening, is basically the measure of how much light a celestial body reflects. And that tells us a lot about its chemical composition, and the ancients seem to have done the exact same thing.
Let's analyze those planetary profiles, because they are striking.
Okay, let's start with the moon. The texts say its chariot is pulled by 10 white horses, and it possesses exactly 3 wheels.
Well, the white horses obviously correlate to the moon's incredibly high albedo, right? It brilliantly reflects white sunlight. But the 3 wheels are purely mathematical.
How so?
They represent the 3 distinct orbital cycles required to accurately track lunar motion. You have the synodic cycle, which tracks the visual phases of the moon from new to full, the sidereal cycle, which measures its actual physical position against the background stars, and the anomalistic cycle, which measures its varying elliptical distance from Earth from perigee to apogee. 3 highly specific mathematical cycles encoded simply as 3 wheels.
That's incredible. Okay, next is Mercury. The texts say Mercury's chariot is pulled by wind-swift horses.
And this aligns flawlessly with Kepler's laws of planetary motion. Mercury is deeply entrenched in the sun's gravity well, right? Which means it must travel at extreme speeds just to maintain its orbit and avoid falling in. It possesses the fastest orbital velocity in the entire solar system, moving at a blistering 47 kilometers per second, completing a full orbit in just 88 Earth days. It is, by pure physical definition, wind-swift.
Makes total sense. Then we reach Mars. The text describes Mars as riding an octagonal golden chariot pulled by horses the color of ruby, born of fire.
And how do modern scientists know the surface composition of Mars? Long before we sent billions of dollars worth of physical rovers there, we used spectroscopy. We analyzed the light bouncing off it. That red ruby color is the exact spectroscopic signature of iron oxide rust. The ancient rishis correctly characterized the chemical reflection of the Martian surface as ruby-colored.
Just from the light. Wow. Okay, what about Jupiter? It's described as having golden or yellow horses.
Again, a completely accurate spectroscopic assessment. Jupiter is a massive gas giant, and it is characterized by these sweeping, turbulent bands of yellow, brown, and gold. Modern science, using tools like Hubble, has identified these bands as massive clouds of ammonia and hydrosulfide in its upper atmosphere.
And finally, Saturn. The text describes an iron chariot pulled by slow, dark, speckled horses.
This one is brilliant because we can deduce Saturn's environment using both the inverse square law of light and Kepler's third law.
Break that down for us.
Sure. Saturn is the furthest visible planet from the sun that you can see with the naked eye. Out in that deep space, solar radiation is incredibly faint, rendering its environment quite dark, hence the iron chariot and the dark horses.
Okay.
Furthermore, because it is so far out, its orbital velocity is sluggish compared to the inner planets. It moves at only 9.6 kilometers per second, taking 29.5 Earth years just to complete a single orbit. So slow dark horses is an exact, literal description of both its deep space environment and its velocity.
It's just wild. Every single detail, from the color of a horse to the speed of a chariot, is a specific mathematical variable for chemical composition and orbital velocity, which honestly means we have to circle back to Rahu, the mathematical anomaly, to decode its physical description in the Vishnu and Matsya Puranas.
Yes, the anatomy of the shadow.
Right. The texts describe Rahu's chariot in 2 very specific terms. It is tamomai, meaning deep, absolute dark, and it is dusar, meaning gray or dusky. So if Rahu is the shadow causing eclipses, how does this map to the modern optics of how shadows actually function in space?
It maps directly to the dual-layered structure of an astronomical shadow. When a massive body like the Earth casts a shadow, it isn't just a uniform block of darkness, right? It is divided by the angles of the light source into 2 very distinct zones. The inner core of the shadow, where the light source is completely 100% blocked, is pitch black. In modern optics, this is called the umbra. This is exactly what the text describes as tamome, the deep dark.
And the dusky gray.
Surrounding that deep umbra is a wider, softer region called the penumbra. Here, the light source is only partially blocked by the curve of the Earth, resulting in a lighter, grayish, gradient shadow. This is the dusor described in the texts. The ancient astronomers precisely identified the umbra and penumbra structure of a celestial shadow.
But the text makes a claim that is conceptually just brilliant. It says, this shadow chariot is always present in space, but it remains entirely invisible until a bright object hides behind it.
And that is a masterful articulation of exactly how light behaves in a vacuum. On Earth, if you shine a flashlight into the sky, the beam is visible because the light scatters off dust, moisture, and air molecules, right?
Right. You see the beam cutting through the air.
But space is a vacuum. There is no atmosphere to scatter the light. So the Earth is constantly casting a shadow millions of miles long out into the void, 24 hours a day, 365 days a year. But because there is nothing out there for the shadow to actually fall upon, you cannot see it.
You only see a shadow if you have a screen to project it onto.
Precisely. The vast shadow of Rahu is always traveling alongside Earth, ever present in the void, but it remains completely invisible to us until a celestial body, specifically the moon, passes through it. The moon becomes the projection screen, and suddenly, this massive, dual-layered chariot of darkness reveals itself.
It's an exact description of eclipse mechanics in a vacuum. And the orbital mechanics they encode go even deeper than that. The texts state that Rahu's horses run backwards. They run in retrograde.
And this is one of their most impressive mathematical deductions, without a doubt. Planets naturally orbit in a prograde motion, which is generally west to east. But remember, Rahu and Ketu, the lunar nodes, are not physical objects with forward kinetic momentum. They are mathematical intersections.
Right.
Due to the complex gravitational torque exerted by the sun and also the Earth's equatorial bulge pulling on the moon's orbit, these intersection points actually slowly drift backward, east to west, along the orbital path.
So they drift against the grain of the solar system.
Exactly. In modern orbital mechanics, this is called nodal precession. It takes approximately 18.6 years for these nodes to complete one full backward cycle through the sky. The ancient astronomers actually tracked and calculated this retrograde nodal precession without modern instruments, encoding it simply as horses running endlessly in reverse.
Which leads to the final and possibly the most mind-bending visual detail from our sources today. The texts describe a flag on Rahu's chariot, specifically a black triangular flag fluttering in the northwest.
Ah, yes. The black triangular flag is truly the crown jewel of their three-dimensional geometry.
Because a shadow cast by a sphere isn't a flat, two-dimensional circle, right?
Correct. When a spherical object, like the Earth, blocks light from a massive source like the sun, the resulting shadow isn't just a straight cylinder stretching forever. Because the sun is much larger than the Earth, the light rays angle inward past the edges of the Earth.
Okay, I see where this is going.
This creates a shadow in three-dimensional space that is physically shaped like a cone. It is a massive three-dimensional cone tapering to a point hundreds of thousands of miles out in space. Now, ancient Indian temple flags were not rectangular like ours, they were triangular pennants.
Oh.
So, when the text describes a black triangular flag trailing the chariot of Rahu, it is literally describing the 3D conical geometry of the umbra shadow stretching out into the void.
Wait, the text explicitly says the flag is fluttering. There's no atmosphere in space, there's no wind. How on earth can a shadow cone flutter?
Because the cosmos is not a rigid clockwork machine, the orbits of the Earth and the Moon are constantly experiencing slight gravitational perturbations.
Like what?
Well, the pull of the Sun, the massive influence of Jupiter as it passes, even the uneven mass distribution of the Earth itself, all these tiny factors cause the Moon's orbit to gently undulate over time. It wobbles.
Orbital wobble.
Exactly. Because the orbital plane wobbles, the intersection point, the node, Rahu does not travel in a perfectly smooth mathematical straight line. It physically moves in a wavy, undulating path through space over its 18.6-year cycle. Now, how do you explain a wavy, undulating, invisible force traversing a vacuum to a civilization living thousands of years ago?
You tell them it's a flag fluttering in the wind.
Exactly. It is a gravitational perturbation translated flawlessly into a visual metaphor. And notice the directional placement. The texts situate this flag in the northwest, which is the domain of Vayu, the air element. In ancient philosophy, the air element represents that which is non-solid, invisible, unstable, and purely characterized by kinetic motion. Rahu is not a rock. It is a region of gravitational instability.
Wow. Okay, let's bring all of this together, because what we have uncovered today is just a profound shift in perspective. These ancient Puranic descriptions are clearly not primitive myths or fairy tales born of ignorance. They are highly sophisticated, mathematically rigorous models of orbital mechanics, quantum physics, spectroscopy, and astrophysics.
Yeah, they took the most complex end-body physics, the exact measurements of solar cores, the dimensions of gravitational hill spheres, and the 3D geometry of eclipses, and they meticulously encoded them into cultural metaphors. Chariots, horses, flags, and Yojanas.
It's brilliant.
They did this so that this immense, fragile knowledge could be memorized, chanted, and passed down flawlessly through the ages, surviving the inevitable rise and collapse of human civilizations. It's an information survival mechanism.
For you listening, I really want you to look at the night sky differently tonight. The next time you see the moon hanging there in the dark, don't just see a cratered piece of rock. Look beyond the visible, see the reality. It's a massive, 132,000-kilometer invisible sphere of gravitational influence, physically gripping our oceans, riding in a chariot of 10 vectors to balance the absolute chaos of gravity.
And, if we connect this to the bigger picture, it really makes you reconsider the trajectory of human knowledge and honestly how we view ourselves today. We look back at their chariots and horses, their legless drivers and fluttering flags, and we so arrogantly call it myth. But think about how we explain quantum physics and astrophysics to the general public today.
Right.
We talk about black holes, even though they aren't actually holes in anything. We talk about the fabric of space-time, even though there is no literal fabric weaving the universe together. We use concepts like strings and wormholes just to make the complex math digestible for human brains.
Oh, wow. I never thought about it like that.
So, if the ancients used chariots to explain orbital vectors to the people of their time, what will civilizations 5,000 years from now think of our current scientific metaphors? Will they look back at our models of the fabric of spacetime and dismiss us, thinking, oh, those primitive 21st century people thought the universe was made of blankets and strings?
That is a staggering final thought. It brings us right back to the beginning, looking into the diagnostic muddy waters of trying to understand the universe. Sometimes the math simply requires a metaphor, and sometimes the poetry is the physics. Thank you so much for joining us on this deep dive. Keep looking up, keep questioning the narrative, and we'll catch you on the next one.